There are other units used for solution concentrations, and we'll talk about those later on. But some ones that are kind of important that pop up once in a while are mass percentage, volume percentage, and parts per million. So we're not going to talk super deep about those right now, but I do want to talk about them, what they are. A mass percent, which is usually solute, will be mass of the component, the solute, divided by mass of the whole solution times 100%. And if you see one of those, it's just something you can deal with. Sometimes it's easier to figure out mass percent than molarity, but honestly, molarity is cooler in my opinion. Now, a volume percentage will be a volume of solute divided by volume of the solution times 100%. These are usually for very specialized procedures, but they do pop in once in a while. Again, they're both percentage. Most of the time in our classes, all the percentages will be mass-based, so they would measure out how much of the component you have in relative to how many grams of the solution you have. But if you do see these, this is what they mean. Here's an example of a mass percentage. Let's say you had 5 grams of a sample, and in that sample you had 3.75 milligrams of glucose. What is the mass percent of the glucose? So this would be grams of the solute glucose divided by total grams of sample times 100%. But notice here we have milligrams. Well, the sample is in grams, so I would convert one into the other. It's probably easier to go milligrams to grams. There's 1,000 milligrams per grams, so 3.75 divided by 1,000 would be the grams of glucose. We'll divide that by the grams of the spinal fluid, which is crazy, and then we'll multiply that by 100%. This comes out to be 0.075% glucose. If you see that, that's what this means. It doesn't happen a lot, but it does happen sometimes. Now you're in the know. Here's an example of a problem too. In this one, we're looking for a volume percentage. So in this question, 50 milliliters of ethylene glycol are added to a radiator with 120 milliliters of water. So you'd have a total volume of 170 milliliters. What's the volume percentage of ethylene glycol? So that'll be the 50 milliliters of ethylene glycol divided by the total volume times 100%. If you do that, it comes out to be 29.4%. Again, we're not going to use mass percentages and volume percentages like this a lot, but if you see them, it's good to know how to handle them. They're pretty chill once you kind of know what's going on. A type of unit you might come in contact with more often is what's called a parts per million. And a part per million, and also the equivalent parts per billion, parts per trillion even sometimes, are used for very low solute concentrations. So if you ever looked at environmental work, like environmental studies, or sometimes the government will use this when talking about water purity, stuff like that, parts per million are used. Now, parts per million is probably the most common, but again, you can have parts per billion, parts per trillion, stuff like that as well. Now, a lot of times these are based in water-based solutions, and they assume for these that the density of water is just 1.00 grams per milliliter, and that can be useful and confusing to the chemist sometimes, but just kind of FYI about that. So in this case, a parts per million would be the mass of the solute, what you're looking at, divided by mass of everything times a million. A million is 10 to the 6. A million has 6 zeros, so that would be 1 with 6 zeros. That's where the million comes from. So parts per billion, same concept, but with 10 to the 9th instead of 10 to the 6th. So parts per million, parts per billion, used for small concentrations of solute. If this solute is a pollutant or a poison to people, then it might be really important. So let's say we have some kind of pollutant. It's 5 milligrams present in 100 grams total. Let's calculate this in parts per million. Now, in order to do this, we need to turn milligrams into grams. And again, there's 1,000 milligrams in 1 gram. So we'll do that first before multiplying by a million. So in this case, 5 milligrams, you divide by 1,000 to turn that into grams. That would be grams of solute, or the mass of solute. We'll divide it by 100 grams total of the solute present and multiply by a million. So if you do this, this comes out to 50 parts per million. So this pollutant is present in 50 parts per million under these cases. Again, it can be useful. It's a very, very small amount, so a lot of times pure chemists don't worry about it, but it's nice to be able to translate this kind of work into things that make sense in terms of molarity and stuff like that.